is Sophia. Thank you for your email. I'm going to do the first question for you here, and I have a feeling that probably that will take as much time on the video as I'm allowed, and then I'll do the second one for you as a second video, okay? So finding the x value of all the points where the function has any relative extrema requires us to find the first derivative, okay? And so f prime of x is going to look like this. It's a quotient rule question, and so we're going to take the derivative of the numerator first, and the derivative of something in the form of 2 to the x is ln 2 times 2 to the x, okay? Then we're going to multiply by the denominator, which is x, and then we're going to subtract the derivative of the denominator, which is 1 times 2 to the x. And so we have 1, and I'm going to run out of space, but 2 to the x, I'll squeeze it in up there. Oh dear, that's messy. Sorry. All right, I'm going to rewrite that one more time just so it's clear and you can see all the pieces. So in order to find the extrema, we're going to take that function, we're going to set it equal to 0. So first thing I'm going to do is I'm going to common factor 2 to the x out of each term, and then I'm going to set it equal to 0. So we have two factors here, and one of them has to equal 0. 2 to the x cannot equal 0 because you have a positive base, and so no matter how small or negative you make the exponent, you're never going to get an answer of 0. So we must have ln of 2 times x minus 1 equal to 0, which means that ln of 2 times x equals 1. And solving for x, we would have 1 over the ln of 2. And you can work that out if you want as a decimal. I think it's like 1.44 or something like that. That's your x value where extrema are going to occur. Now you need to test to see whether that's a maximum or a minimum. There's two ways to do that. The first way would be to take the second derivative. I forgot in my first derivative, I forgot it was a quotient rule. It's all over x squared, which isn't going to make any difference to the final answer because you just bring that up here and times it by 0, so it's gone anyway. It would be a little more difficult to take the second derivative of a function like this. I would probably opt for doing a chart to test and see whether it's a max or min. And by chart, I mean that we are going to put in the value that we found, x equals 1 over ln of 2. And then what we're going to do is try to take a value of x that's less than that and a value of x that's greater than that. We know it's equal to exactly 0 at that value. And you're going to test to see whether you get a positive or a negative answer. For a value less than 1 over ln 2 and a value of greater than 1 over ln 2. So 1 will be like a negative, 1 will be a positive, and I'll leave it up to you to investigate. And so if you're going from negative to positive, then it's kind of doing that, right? Which means that the value that you found, the critical point, is going to be a minimum. If it's going from positive to negative, it's going to be doing that, so the value you found is up here, and it's going from a positive to a negative, which means it's a maximum. And so the last step is to find the values of any extrema, is to take this value, go back to the original function, because f of x is the same thing as y equals. Put that value in for x and work out what y equals so that you can say you have a max at 1 over ln 2 for the x value and whatever you get for the y value, so that you can give the coordinates of that point and then say that it's a maximum or a minimum point.